All right, here we go, but to dial it in. Cumulative Review 17. Holy buckets. It's the last one of the year. Try to contain your emotions. All right, try not to cry. I'm going to do my best not to cry during this as well. Okay. Said I wouldn't do it. So, write as a single trig function. After you have a single trig function, find the exact answer, blah, blah, blah. So, what we need to do is recognize, all right, whether or not this is, already? Are you kidding me? There we go. So, I need to recognize whether or not this is a sum or difference formula, number one, and whether it's sine or cosine, okay? Because, remember, you would just look at a reference sheet for this, or look at a reference sheet for this, all right? But because it's cosine, minus sine, all right, cosine of one angle times cosine of another minus sine of one angle times sine of another, this is going to be a cosine sum formula, okay? Because in cosine, the signs are the opposite. So this is the cosine of 225 degrees. And if I go to my unit circle, I realize that that is negative root 2 over 2. Remember, unit circle is always cosine, comma sine. Okay, each individual point is cosine, comma sine. All right. The hardest part about these is recognizing which sum and difference formula I'm going to be using. Okay, that's the toughest one. All right. When it says write as a single trig function and I have a subtraction there, I know to look at my sum and difference formulas. Okay. Same thing with number 2. All right. All there is tangent in here, right? So that tells me right away it's going to be the tangent of something. Okay. That tells me right away that I'm going to have to use tangent. All right. And now I recognize that I have this 23 pi over 15. And I have pi over 5, excuse me. Well, I want to have this in terms of, I want to have a common denominator here. So I'm going to multiply the top and the bottom by 3 just right away. So I have 3 pi over 15. The next thing I got to do is recognize whether this is a sum or difference formula for tangent. Okay? Because it's subtraction on the top and addition on the bottom. If you look at your reference sheet, you should realize that it's subtraction. It's a difference. Okay. Remember now, the reason I changed this to a common denominator was so I could subtract these two fractions. So if I do 23 minus 3, I get 20 pi over 15. It's a tangent of that. Well, if I were to simplify, if I were to reduce that fraction, 20 pi over 15 actually becomes the tangent of 4 pi over 3, which, if you look on the unit circle, is right there. It's in quadrant 3. Okay, if it's in quadrant 3, I know tangent's going to be positive. All right, remember, tangent is y sine over cosine, or y over x. Okay, if it's y over x, it's going to be negative root 3 over 2 over negative 1/2. I'm just going to do this work. You may have it already written down in unit circle, and that's fine. Divide by a fraction, multiply by the reciprocal. 2's cancel, negatives cancel, so I get root 3. You may have that. You may have had this on your unit circle already. I just want to show how you would get that. Okay. Okay. Oh, remember these ones. These are so much fun. Contain the excitement. So much excitement in one little video. I don't know what you guys are going to do without this class in about a month. I'm going to start crying. Keep it together. All right, so both in quadrant 3. So I'm going to draw a little triangle. 2 triangles in quadrant 3. Okay. Here's my right angle. One's going to be x. The other one is going to be y. All right. I know that the cosine of x is negative 3 over 5, and remember that cosine is adjacent over hypotenuse, so this should be negative 3, and this should be 5. Well, my triples is a triple, 3, 4, 5, so this side needs to be 4, and if you think about it, since I'm going down, it's going to be negative 4. Alright. Same deal here. I have sine of y. That's opposite over hypotenuse. Okay. So opposite would be -5. Hypotenuse would be 13. This is a triple. 5, 12, 13. Well, if I'm moving to the left, that should be a negative. Okay. Next thing I want to do with this problem is figure out, alright, well, I have the sine of x minus y. Now, this is not, please do not make this mistake, the sine of x minus y. This is not the sine, this is not just, alright, sine of x, -4 over 5, minus sine of y, -5 over 13. This is not that. Do not make that mistake. Okay? When solving one of these problems, I need to use the sum and difference formulas. This is a sine difference formula. Okay? The sine difference formula looks like this. Sine of x, cosine, sorry, it's happening again. Cosine of y. And you may think, why use that computer over and over again? Well, I don't have much of a choice. Cosine, oh buckets, I'm going to start crying, of y. Okay, I got to pause. Alright, so I read ahead and rewrote that for you. Sine of x, cosine y, minus cosine x, sine of y. So sine of x, I go over to my triangle with my angle x. The sine is going to be -4 over 5. Cosine of y, go over to my triangle with y. Cosine is adjacent over hypotenuse, -12 over 13. Minus cosine of x. Cosine of x, adjacent over hypotenuse, and you're also giving it up here, -3 over 5. And then sine of y, which you were given here, -5 over 13. Okay? Multiply these fractions. Alright, so 4 times 12, okay, you get 48. It's a negative times a negative, so this 48 is going to be positive. And then 5 times 13, 65. Negative times a negative again. Alright, the subtraction here stays the same. -3 times -5 gives me positive 15 over 65. I got my common denominator, so just subtract 33 over 65. Wow. Okay. Cosine of 2x. Cosine of 2x is not the same as 2 times the cosine of x. This is not what we're looking for here. That is incorrect. Cosine of x is a double angle formula. You must look at your reference sheet anytime you see 2x in there. Look at the double angle formula. So that becomes cosine squared x minus sine squared x. Alright? Well, I know the cosine of x is -3 over 5, and the sine of x is -4 over 5. So I do -3 over 5 quantity squared minus -4 over 5 quantity squared. That's a parentheses. Alright, well, I know that -3 squared, so -3 times -3 gives me positive 9 over 5 squared, which is 25. Just when you're squaring a fraction, remember you square the numerator and then square the denominator. Minus -4 squared is 16 over 25. Now you have to be careful when doing this in your calculator. Obviously, you should know what -3 squared is. Okay, you should know that -3 times -3 is positive 9. If I'm inputting a negative and squaring it into my calculator, a common mistake, you must use parentheses. Alright, I must use parentheses. You have to. Even if you're doing the fraction, same thing. Okay, you must use parentheses. Alright, otherwise your calculator will make a mistake. You don't want to get a problem wrong because of a calculator error. Then I subtract across the top because they have a common denominator and get -7 over 25. Wow. 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 Okay. Evaluate using a sum or difference formula. Well, boom, that should tell you right away that I need to go to my sum and difference formula for tangent, since we're doing tangent, and pick one. Okay. Well, how do I know what to pick? All right. Well, I can use the sum or the difference. It doesn't matter. You'll still end up getting the same answer. But I chose to do buckets. Hold on. So now, you can make the same mistake I did and use a multiple, a angle with a reference of 30. Okay, but I want to avoid anything where my reference angle is 30. Okay, what I want to do is use a 45 or 60 degree reference angle. So I chose 315 plus 60. The reason for that is if I use 30, I'm going to deal with root 3 over 3. You don't want fractions within fractions. It makes things a lot messier. Okay, that should be a 60. Sorry, it's a terrible 0. All right, so if I use my sum formula, that's going to be the tangent of 315 plus the tangent of 60 all over 1 minus the tangent of 315 times the tangent of 60. And I'll probably just do number 4 and then we'll pause from here after here. Okay. Tangent of 315, if you look at your unit circle, all right, tangent of 315 is going to be negative root 2 over that, which should be give me negative 1. Okay. Plus tangent of 60, which should be right up here, is going to be root 3. 1 minus negative 1 root 3. Which will give me negative 1 plus root 3 over 1 plus root 3. Now remember, I cannot have a radical in my denominator, so I have to multiply the top and the bottom by the conjugate. Multiply my numerator and denominator by the conjugate. Boom, just like that. Okay, you quote-unquote FOIL it out. Multiply the top. Multiply the bottom, the top multiplied, if I FOIL this out, would end up being negative 1 plus 2 root 3. Then root 3 minus root 3, okay, is root 3 times root 3 is root 9. Okay, so the square root of 9 is just 3. Now how did I get this? I have negative 1 times negative root 3 to give me positive root 3, and then I have a positive root 3 here as well. Whenever I FOIL this out, remember I'll show you the work here, but shortcut, your root 3's, all your radicals cancel out. See, just like that. So I end up getting on top, I get negative 4 plus 2 root 3 all over negative 2. And simplify it out. Negative 4 divided by negative 2 is 2. 2 divided by negative 2 is minus root 3. Alright, and we are going to stop there for this one, and then I'll come back with number 5 in the next video.